resistance, capacitors, and diodes. And I will use a software to explain better this theme, and, and then I will show you a real circuit in a prototype. So the software that I will use is Livewire. Livewire is a software dedicated to build circuits. So I will start with a serial circuit, and the device that I will use is a resistor. So the resistor you can find in the passive components, and here I will put two resistors right here, and I need power supply like a battery on ground. So okay, I need to connect the resistance in series like this. Sorry. Here. And I will use 5 voltage here. So I will start the program here, and now we can see the current flow, and you can see it's the same current flow in every place of the circuit. 2.5, 2.5, 2.5. So I will write the name of the circuit is circuit, and now this equation. The resistance equivalent of this circuit is R1 plus R2. Here is R1 and here is R2, and the resistance equivalent in this case is 2. And now is the turn of the parallel circuit with resistance. So I need battery, ground, and two resistance first component resistance. To build a parallel circuit, we need to put the resistance parallel to connect in this form here, like this. So if we run the program, so I will write parallel with Now I will run the program to see how the current flow. So here is the current flow through the circuit. So you can see that in parallel circuits the current in each smash are different. In this smash, mash are 18, and here you can see that is 9, and the voltage in each resistance are the same. So here 9 voltage and here 9 voltage. So I forgot to one thing in series circuits, that in series circuits the voltage is different in each resistance. So because in each resistance the voltage is lost. So I will write. So I need to stop the program. I will write the equation of parallel circuits. Parallel circuits equation is like this: R equivalent is equal to R1 times R2 and divided to put together, divided R1 plus R2, right here. And in this circuit the resistance equivalent is 500 ohms. So now it is turn to, to the combination of these circuits. So for example, and I can put one here and one here, and to connect each resistance. And the power supply like battery, and the ground, and here. So in this case we have to combine the circuit that we can see here, the serial circuit, and here is in 1 plus 1 2, and the parallel of this here, and I will write this. For example, here we can see that is serial. So parallel equivalent is was 2 2000 and now is like put like this. So now we can see that this resistance is in parallel. So the equation in this case is R2 so I will put the number equivalent 1 and here 2. So it's like this plus 2 sorry this times 2 and divided 1 plus 2. So this is in 2 is 2 plus 3 is equal to 2 plus 3 cable. So the circuit now that we will have like this two, sorry I need to calculate. So this is equivalent to what and 2 divided 3 and 0.666. So k ohm. So to finish the circuit, the equivalent circuit is uh, 1000 ohm plus 0.66 k ohm. So is 1660 ohms, and the circuit's equivalent is like this with just one. And now you can see series circuits and parallel circuits, but in this case is with capacitors. In capacitors is different because in series circuits the equation is this. So C1 C equivalent is equal to C1 times C2 divided C1 plus C2. So remember that in resistance, in the equation in series circuits was R1 plus R2. So in this case, with capacitors, it's different. So it's upside down, and the parallel is C equivalent is equal to C. In this case, it's C3 and C4 plus C4, and here the result is 1 microfarads, and 1 times 1 is equal to 1, and divided 1 times, sorry, 1 plus 1 are 2, and then is 0.5 microfarads. And here is equal to microfarads. And the current, you can see here the current, but the capacitor has to charge, and when the capacitor is charged and the current don't flow, the process of charge is too fast in the capacitor. So for that, it's difficult to see in the simulator. So now I will explain the process with diodes. Here I will write a diode like parallel, parallel, and series. So I will find no, and I need a battery and the ground. So the components no. Here, here is the diode. There is a different kind of diode like Zener diode, thyristor diode, and in this case a bridge rectifier uh, with diodes. So here, right. So I will run the program, and you can see that the current flow and the mass is in this direction, So the principles of diode is that the current flow just in one direction, and the direction you can see that is in this direction, because if you put the diode upside down, the current don't will flow, not will flow to, to the diode. You can see that it doesn't work, the diode doesn't work in this direction, and there is a different kind of diode like LED. LED means in light emitter diode, and for explain, and of components here is LED. It's a kind of diode, but it's more, but this emit light. So right here you can see the light of diode. In this case is red, and here the current. So now I will show you in this all of the circuit that I built in this video in a real time.
So here we have the circuits that we built in this video, and in the protocol. So here is three resistors that are in parallel, and here four resistors that are in series, 1, 2, and 3, and 4. And here have three capacitors in parallel, and here three capacitors in series. And here we can see a diode. So these are some circuits that we can see, we can build in a protocol. So here we have the circuits that we built in this video, and in the protocol. So here is three resistors that are in parallel, and here four resistors that are in series, 1, 2, and 3, and 4. And here have three capacitors in parallel, and here three capacitors in series. And here we can see a diode.